Hi, and welcome to Serial Killers, a podcast all about the pests, diseases, and weeds that attack arable crops. I'm your host, Dr. Russell Sharp of Nutrima, and I'll be joined by my co-host, Josie. Each week, we'll do a deep dive into one particular problem found on cereal crops. Hi, and welcome to what is our second podcast on blackgrass. So in the first podcast, I sort of teased that we were developing a biological solution for blackgrass. And in this podcast, I'm going to go far more in detail about what that biological solution is. So I'm not with my usual co-host Josie today because this is a project that she's not working on, but it's a project that you can't actually buy at the moment. It's not for sale because all the farm trials were set up in November through to January. And I also hate podcasts that try and sell to you. So I've never, ever tried to push products on this. It's always about information and developing a community around integrated pest management. And so hopefully this will still be of interest to you. And come next year when more spores are available, you'll be interested then. So Blackgrass Spore Project, if you've been following us on social media, you'll have heard loads about it. We're looking at a biological solution for blackgrass that involves giving the blackgrass a disease. So just a quick recap about how bad the problem of blackgrass is if you need it. So blackgrass is estimated to cost £1 billion a year to UK agriculture, but that is a very debatable figure. Yield losses from just 25 plants per square metre can be 10%, and the distribution of blackgrass is the south east of England, but right through the Midlands all the way up to the Humber, across to sort of the Birmingham way, and then it sort of tails out. There's none in Wales or Scotland much at the moment, and herbicide resistance is increasing. So not only are the chemicals we've got at the moment not effective, they're going to get less effective in the future. And blackgrass is a major host for diseases such as take-all and ergot. And ergot's a particular problem because not only is it affecting your yield, it's affecting the quality and whether your crop gets accepted or rejected. So the status quo is the use of pre-emergence herbicides, spraying off crops if it gets really bad, playing around with your planting densities, delaying your drilling, use of spring barley, potential for very expensive toppers, and grinding the straw and things like this when it comes out of the combine. They're all potential options, and that's the status quo. And there is no biological control method at the moment. Whereas if you think of an integrated pest or weed management system, you're always going to look for cultural control, chemical control, and also biological control. And we need a biological control method that is compatible with the other techniques. So we don't want to move away from chemistry, because with the chances of a biological solution being 100% effective and curing it is very slim. It's fanciful to suggest that it would be. So any solution has to be working in line with current practices as well. You know, it can't require farmers to do anything in particular that's going to take massive new machinery or take loads of their time. So that's something we've had to consider. So why has a biological solution not occurred before? And there's a few reasons for that. So the use of plant pathogens to control weeds has been tried before, but the shelf life of the products is very low. And that's because you need to use fresh spores. And if you think of an agrochemical company, the first thing they want to do is put it in a liquid formulation, and those spores just germinate straight away. So that's one reason. And the second reason is it's not easy. It's a difficult process. And the other reason is that it's the conventional chemistry has been the preferred option until now. The actual technology has been around since the 1950s. During the Cold War, the Americans and the British developed rust bombs, and these would fly over the Soviet Union and release on the spores of rust on the feathers of birds over the Soviet wheat crop, and it would give it rust. It was proven to be effective in trials in the South Pacific and in Texas, and it would only... The reason it's promising from a biological control method is that it was specific to Russian wheat varieties and not American or Western varieties that we were using at the time, or supposedly. And so the selectivity of that is really interesting. And so if you think about using diseases to control weeds, if you chose a weed that was completely unrelated to wheat, then the chances of it being cross-infected would be zero. And that's what we've done with blackgrass. The reason we've chosen blackgrass as our first sort of target species is because it is so unrelated to wheat. So any disease we try and control it, we know won't affect the wheat itself. And so it's a completely selective process. Other reasons that no one's really developed a biological solution before is that the technology to create the product was not available until 2016. So I can't go into the details of what that technology is, but it didn't exist until 2016. And so that's one of the reasons why no one's ever looked at this way of doing it before. And then the other reason is that the biological methods on their own do not kill the weeds. They're not herbicides. They just stop the growth, reduce the growth, make the plant ill. And then it's actually the cereal crop that kills the weed, because if you think about it, a blackgrass plant that can't get up and grow and compete for light, nutrients, water, soil space, it's just going to die off. And so especially with something like a hybrid barley, something really vigorous, that's the way we're looking at it. So before, people are looking at sort of screening pathogens, and they're looking for a sort of a herbicide or a bi-herbicide effect where total kill is important. And we're not doing that. We're looking for control of growth and smothering of the crop. So progress we've made so far is we actually, early on last year, we got farmers to send in samples of the blackgrass from around the country. We got about 100 samples sent in, and we screened them all for diseases, and we found a couple of diseases we were interested in, and we're now propagating those in the lab and collecting the spores, and then we're delivering those spores in a form that they can actually be applied fresh to trials in the spring. So from early spring through to early summer, we'll be sending out spores, billions and billions of spores per hectare, and farmers will be tank mixing this and then applying that on the trial sites. So we've got about 15 farmers who've helpfully contributed to the trial costs, and that's going to be delivered, and we'll get results back from that. We've also got a trial over at Lamport in Northamptonshire with Agravista, and any farmers who are interested can go and see the results of that in the summer. So it may not work. It works really well in the greenhouse and in the grow room, but obviously we know that technology doesn't always transfer into the field, and we need to see a significant economic effect on the farm first. And then if it does work, we'll be building it up and bulking it up, and even more farms I think will come on stream next year once we've got trial results. So the cost was very low because it was basically a contribution to the trial costs. It wasn't a full economic costs. And we know that farmers also spending hundreds of thousands of pounds on chemical control, and the margins are very slim on this. So we're looking for a pathogen that doesn't attack any crop. We're looking for non-hazardous to humans as well. So, couldn't be Legionnaire's disease or anything like that. Needs to be a pathogen that's going to be harmless to humans. And so the caveat to that is that any farmer should be avoiding inhaling large volumes of spores. It doesn't matter what the microbe is, because you get something called farmer's lung, which anyone who's had it will know is a debilitating disease. It's caused just by the buildup of fungal spores in the lungs, and so you need to avoid, when you're handling spores, just use proper precautions and face mask. Plenty of those hanging around since COVID, so that's one of the issues. And obviously another point is that any technology has to be compatible with co-applied agrochemicals. So the idea is that these spores go on anytime the farmer is applying an agrochemical that's not a fungicide, because obviously a fungicide would inhibit the action of the actual fungus itself on the blackgrass. So we've tested compatibility with insecticides and nutrients and things like that. So as long as you avoid fungicides or copper-based, zinc-based fertilizers in high concentrations, it should be fine. And that's the key, really. We're not expecting you to go on and apply just this few spores on their own. I say a few. It looks small because it's in like a test tube, but actually there's we're talking billions per hectare. I worked out what people had done in the past, how many they'd applied per hectare, and then times that by 4 because I want as many spores going on the field as possible, so we stand a really good chance of affecting it. And I say we're focusing on blackgrass. We are going to look at Italian. We've got trials set up looking at Italian ryegrass, perennial ryegrass, and rat's tail fescue. We've chosen these as our next ones because feedback from farmers has said that Italian and perennial ryegrass are number one weeds after that they struggle to control, and because they are unrelated to cereal crops. So and rat's tail fescue, we've chosen that because we've got a lot of really passionate customers for our other products in the northeast, and there blackgrass is not an issue, but rat's tail fescue is a significant issue. So we're helping them out by sticking that on the target list after perennial ryegrass and Italian ryegrass. And then last on the list would be things like bromes or wild oats, because they get closer to the actual cereal crops genetically, and so they stand more chance of actually cross infection. Still very unlikely, but they're not my first choice. So that's that. You might have seen us at Crop Tech. We exhibited some of the infected plants at Crop Tech. And we'll be at groundswell and cereals if everything works splendidly this spring. So if you see us there, you'll know that the trials have gone well, and we'll be bulking up and massively increasing our production for next year. And so we'll probably, as soon as we've seen good effects in the summer, we'll be opening the project back up for new entrants and signing everyone up, and it'll probably close again this year. It was the 5th of January. So we'll probably close it again that time so that we can guarantee the number of spores that we have for each farm. So we have a set billion number of spores that we want to hit per hectare, and we deliver that 4 times in the spring this year. That might change slightly next year based on this year's results, but we need reliable numbers of farmers. We can't add somebody in March or April to the program because we won't have spores available, and we don't want to dilute what we already have. So that's why there's that sort of gap between the project closing and then the spores being delivered. So the spores are actually delivered in as a dry form, a dry powder, and that's just a pure concentrated form of the spores themselves. So there are hundreds of billions of spores per gram, and we either deliver that in vials or test tubes, depending on how many hectares you've signed up for. And then we think about the potential outcomes. I mean, the best case scenario is that blackgrass growth was impeded to the point where the crop smothers it out and chokes it out. That's the best case scenario. And there could be synergistic interactions with herbicides. So it might work better than it works in the grow room, because if you think about it, you're throwing herbicides at this weed. Those herbicides are damaging the weed, and therefore you've got damaged blackgrass, whereas we're working with beautifully healthy blackgrass and still getting infections. Whereas if you're creating a wound site for those spores to germinate through, then that can increase the effect. And the same goes the other way. If you've produced a wounded, ill, diseased weed, then the chemistry might work better. You think about when you spray a liquid onto blackgrass, the droplets easily fall off, and that's why we use spreaders and wetters and things like that. But where there's a lesion, where there's a mildew, those water droplets stay on, and that's because the hydrophobic surface of the leaf has been broken down, and it's in the mildew or the rust's interest to actually be hydrophilic, to absorb water, because then those spores get absorbed on. And so you'll notice this on any hydrophobic leaf surface. Once it's infected, the water gets absorbed easily. And so if you think about you spraying an herbicide, you're going to get less bounce off on infected blackgrass plants. Another point to consider is that blackgrass pathogens are already there in the field, but they take a long time to build up. And so we're going in there early spring and getting these diseases that you would not normally see on blackgrass until, say, October time, on in February, March and April. And so that's another key thing to look at. We're not introducing some really foreign pathogen. We're just introducing what's already in the UK back into farms on the UK, but just in a higher dose rate and targeted on the leaf. Okay, we're not waiting for it to blow in the wind in October. Worst case scenario for this project is that we have no effect on the weed and that blackgrass continues to spread and further resistance to agrochemicals. And that's a real possibility. We just don't know the results yet. We have got some really good lab results. We've got some great pictures of mildew spores that we've collected from our lab in our production and seen them germinated, and we monitor their viability every few weeks to make sure that they're still viable, the ones we've collected, and that will be ongoing. So if you are interested in the blackgrass project, and say it's not open for sign-ups, but if you're interested, do get in touch with us and we can add you to the list of people to contact. We have a mailing list for people where we do technical updates. It's not we don't spam you with buy this product now or anything like that. We literally, if we've got something interesting to say, an update technically on the project, then we email people, and that's once every few months really. So yeah, hopefully you're interested in looking at this, and I'll probably do an update around May time, say whether this project worked or if it failed. And hopefully we'll do another podcast soon, go back to the ones where Josie hosts, and we'll have a bit more, less dry technical details and a bit more of a to and fro, a few of Josie's jokes dropped in there. So until next time, thanks very much for listening. Goodbye.